This video discusses what's called the quotient rule. And so if you are trying to take the derivative of the quotient of two functions, so we've got a division problem here of two functions, then we have to follow these steps. And the way that we're going to do that is we're going to take the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. So again, if you read through that, it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So we have y equals x squared plus x minus 2 over x cubed plus 6. I'm dividing two polynomials here. I want to find the derivative of y, so I'm going to use the quotient rule. Y prime is going to equal the bottom, which would be x cubed plus 6, times the derivative of the top. So the derivative of x squared is 2x. The derivative of x is 1. The constant goes away. Minus the top times the derivative of the bottom. Derivative of x cubed is 3x squared, and the 6 will go away. All over the bottom squared. And again, don't worry about simplifying here, just like the product rule. We're just going to leave it like this. There will be a time when we may want to simplify this, but if we are just trying to find the first derivative, there's no need to try to simplify. Oftentimes, you'll end up making a small mistake that will change the value of this. So we're just going to leave it like this and work with that. Another example, g of x equals 2 over x to the fourth. Use the quotient rule. So I'm going to use the quotient rule here, and then I'm going to show you why the quotient rule would not be the best option here, or the quickest option, but we will get the same answer. So I'm going to find g prime using the quotient rule. So that's going to be the bottom times the derivative of the top. Well, the derivative of 2, that's a constant, that's 0, minus the top times the derivative of the bottom, which would be 4x to the third, all over the bottom squared, which would be x to the fourth squared. Now, I am going to simplify this. I just told you not to, but I'm going to go ahead and do it just to show you that it really wasn't in our best interest to use the quotient rule here, even though it's not challenging. There was a quicker way to do this. So on top, the x to the fourth times 0 goes away. I've really just got negative 8x to the third on top, and on bottom I have x to the 8th, which means we really just have negative 8 over x to the 5th, or negative 8x to the negative 5th, right? That's what negative 8 over x to the 5th it means. It's negative 8x to the negative 5th power. Well, if you look at your original problem here, we have 2 over x to the 4th. Hopefully you remember from the power rule video, I could have just rewritten that as 2x to the negative 4th. And then using the power rule, I would multiply down, and I would subtract 1 from the exponent. And that's what I got. Now, I'm not saying here that the quotient rule is unnecessary. I'm just saying for this problem it was unnecessary, and that's because the numerator was a constant. So if the numerator is a constant, don't get stuck in, oh, it's a fraction, I've got to use the quotient rule. Think about, could you rewrite this to make it simpler so that you don't have to use the quotient rule? And that's oftentimes going to be much quicker than doing the quotient rule.